You know, some dates just have a certain ring to them, right? They seem to pop up in history over and over again. But what if I told you there's one specific day that has this secret connection to some of the most brilliant minds in mathematics? Let's dig in and find out what it is.
So here it is, April 24th. Why this day? What on earth could possibly connect a master of puzzles, a top-secret codebreaker, and a guy who designed supersonic jets? Well, the answer is this single date.
On this very day, spanning different centuries and in totally different parts of the world, these incredible minds were either born or passed away, and each one of them left a mark that literally changed our world. So we're going to meet them one by one and uncover the amazing stories that are all tied together by this one golden day in math.
Okay, let's start with a puzzle. It's almost like a magic trick. Imagine you've got a perfect equilateral triangle sitting in front of you. Now, is it possible, with just a few straight cuts, to rearrange those pieces and form a perfect square with nothing left over? It sounds impossible, doesn't it?
Well, the answer comes from this man right here, Ernest Dudeney. He was an absolute master of mathematical puzzles and pastimes. And, you guessed it, our story connects with him on April 24th, 1930, the day he passed away.
This incredibly elegant solution is known as his famous Haberdasher's problem. See, Dudeney's genius was in seeing the hidden geometry, the secret connection between these two completely different shapes. He was so proud of this thing, he actually showed off a hinged wooden model of it at a meeting of the Royal Society. This is what he did best, creating problems that were not only fun, but also deeply, beautifully mathematical. And here's the really amazing part. Dudeney truly believed that the whole history of puzzles was really the story of humanity learning how to think logically. So every time you play a game of chess or solve a Sudoku or just wrestle with a brain teaser, you're basically following in the footsteps of a puzzle master like Henry Dudeney.
All right, but our journey through April 24th isn't over. Let's leave the world of these gentlemanly puzzles behind and jump into a much more dangerous world, one of secrets, spies, and the very dawn of the computer age.
Just picture it. It's the middle of a massive global conflict. Secret messages are flying back and forth, and the key to winning could be cracking the enemy's codes. But the computers back then, they were primitive, clunky, and so limited. So how did mathematicians manage to push these basic machines to their absolute limits to uncover those vital secrets?
Well, the answer leads us straight to this man, the Scottish mathematician Walter Douglas Munn. And he was born on, you already know, April 24th, 1929.
Now, the funny thing is, Munn often called his own work pure mathematics and claimed it had no practical application whatsoever. But during his time in the military, he worked at GCHQ, Britain's top-secret code-breaking headquarters. And there, his super abstract work on algebra, specifically on something called semigroups, was anything but useless. He was on the cutting edge of early computing, figuring out how to get these machines to solve problems that seemed way too complex for them.
And it just nails the point, doesn't it? These incredibly abstract ideas, the kind that seem to only exist on a chalkboard, can suddenly become the most critical tool for national security or for huge technological breakthroughs. It's just a powerful reminder of how these hidden connections can drive everything forward.
Okay, we've got one more stop to make on our trip through April 24th. We've had puzzles, we've had secrets. Now, let's talk about speed. I mean pure, raw, faster-than-sound speed.
It's a huge question in engineering. If you want to build the fastest jet fighter or the most efficient rocket, what is the absolute best shape? You know, the one that just slices through the air with the least possible amount of drag once you've broken the sound barrier?
For that answer, we need to turn to the German mathematician and aerodynamicist Wolfgang Haack. And I think you know where this is going. He was born on April 24th, 1902.
Now, Haack's incredible achievement was that he solved this problem not in a wind tunnel with a bunch of physical models, but with pure mathematics. He used these complex calculations to define the perfect shape for supersonic travel, a shape that gives you maximum speed and efficiency. His work ended up being massively influential in designing high-speed aircraft. So just think about that for a second. The sleek, powerful shape of a supersonic jet wasn't just found through trial and error. It was born from equations on a piece of paper. I mean, that is the incredible power of math, to not just describe our physical world, but to actually shape it.
So let's just put this all together. Here's our timeline, all filled in. In 1902, a German aerodynamicist is born. 27 years later, a Scottish codebreaker is born. And just 1 year after that, an English puzzle master passes away.
3 totally different lives, 3 different fields of study, all connected by this one single day, April 24th.
So what really connects them, besides just a date on the calendar? Well, Dudeney looked at a jumble of shapes and saw a hidden pattern that can make a beautiful puzzle. Munn looked at abstract algebra and found a hidden pattern that could break codes. And Haack looked at the chaotic physics of airflow and discovered the mathematical pattern for the perfect shape. They were all, at their core, pattern finders.
Their hunt for patterns gave us things we literally use and see every day. The logic behind our games, the foundations of modern computing, and the design of the fastest vehicles on the planet. And all of that kind of makes you wonder, what hidden patterns are all around you, right now, just waiting